what is two alternative sign here? That is nothing but the one is negative sign and one is positive sign. What is x naught here? That is nothing but the root. That is nothing but the starting position. In my Newton-Raphson method, whatever the smallest root I have, that is my x naught value. If I consider Newton-Raphson formula, what are the things I required? I required x naught. Hello to all, a warm welcome to my new session on roots of equation. I'm Revati from the Department of Computer Science, Vidhyaashram, first grade college, the Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let me to recall the topic which I have discussed in my last session. So dear student, I have started with regular falsy method. Then what is the formula? You have to remember that is A into f of b minus b into f of a whole divided by f of b minus f of a. So this is the formula you have to remember while solving any problem under regular falsy method. And this same regular falsy method is also known by the name false position. So dear student, in the question paper, you may get the question like solve the given problem by using false position method or regular falsy method, and this method is very important. Now in my today's session, I'm going to discuss another iterative method, that is Newton-Raphson method. So it's also called by the name NR method, that is nothing but Newton-Raphson method. Now to solve the problem under this method, we have to remember the formula, that is xn plus 1 equal to xn minus f of xn whole divided by f dash of xn. So it is f of xn divided by f dash of xn. That means I want to divide only f of xn divided by f dash of xn, and whatever the answer I'm going to get, I want to subtract this one from xn. So this is my general formula. Now suppose if I want to perform first iteration, then I have x1. This is my step 1 or first iteration. Then x naught minus f of x naught divided by f dash of x naught. So this is my first iteration. And for the second iteration, x2 equal to x1 minus f of x1 divided by f dash of x1. Now my third iteration, x3 equal to x2 minus f of x2 f dash of x2. Now tell me dear student, what is x naught here? That is nothing but the root, that is nothing but the starting position. Or if I get the question like root lies between 2 and 3. In this, which one is my x naught? That is nothing but this 2. That is nothing but the starting root. Now, what about f of x naught? That is nothing but the equation. That means whatever the equation we are going to have, that is written in the form of f of x naught. So, what is f dash of x naught? That is nothing but I want to differentiate the equation. So what is the formula I need to remember here? That is xn plus 1 equal to xn minus f of xn divided by f dash of xn. Now, dear student, I am going to have my first problem, that is use Newton-Raphson method to find out a real root of the equation. What's the equation I have? X cube minus 2x minus 5, which is equal to 0 and correct to 3 decimal places. So, what is the question here? This equation is solved by using Newton-Raphson method, and here I am not going to have any root. That means they did not specify any root and they just given the hint that where I want to stop the iteration. So where I want to stop the iteration? Correct to 3 decimal place. That means before going to stop my iteration, I want to consider 2 iteration. That is the consecutive 2 iteration, and in that I want to consider 3 decimal place. In both the iteration, if I have same decimal numbers, then I can able to stop the iteration. Now, let me to solve this problem. What I want to do? First, I want to write the given equation in the form of f of x. So, I have written the given equation in the form of f of x. Now, in the question, they did not mention where the root lies. So, what I want to do? I want to start with the trial and error method. So, what I will do? I am going to start substituting x value. So, put x equal to 0. Now, f of x. So, f of x is what? That is f of 0 equal to 0 cube minus 2 into 0 minus 5. What is the answer? I am going to get minus 5. Now, next time, put x equal to 1. F of 1 minus 2 minus 5. Once again, it is minus 3. So, dear student, I am getting negative answer. Now, what I am going to do? Put x equal to 2. When I substitute x equal to 2, I am going to get the answer minus 1. Now, once again, I am going to increment x by 1. Now, x equal to 3. Now, put x equal to 3. When I substitute x equal to 3, I am going to get the answer 16. Now, when I want to stop the process, when I get 2 alternative sign. So, what is 2 alternative sign here? That is nothing but the one is negative sign and one is positive sign. So, here I got negative and here I got positive. So, I am going to write the conclusion that the root lies between 2 and 3. Okay, so it's just approximate root. That means the root may lies between 2 and 3. So, a real root lies in 2 and 3. Now, dear student, I want to find the x0 value. And how I am going to consider x0 value? That is whatever my first root I have. That's my x0 value. So, here what is my first root? I have 2 and 3. In that, which is my first one? The smallest one, that is 2. So, I am going to consider x0 equal to 2. Now, I have Newton-Raphson formula, that is x n plus 1 equal to xn minus f of xn divided by f dash of xn. This is my Newton-Raphson formula. Now, see here, x1, this is my first iteration. So x1 equal to x0 minus f of x0 divided by f dash of x0. So what is x0 here? That is 2. See, now what about f of x0? That's nothing but f of x. So what is f of x? That is the given equation. So x cube minus 2x minus 5. Then what about f dash of x? That means I want to differentiate. So what I will do, I'll write d divided by dx of x cube minus 2x minus 5. So dear student, when I take the differentiation of x cube, I'll get 3x square minus, what is the differentiation of x? That is 1. So 2 into 1, it is 2. And if I take the differentiation of any constant, I'm getting 0. So what is the answer I'm getting here? 3x square. Now I know what is my x0 value, that is 2. I know what is my f of x, that is nothing but the given equation. And what about f dash of x? That is nothing but the differentiation of given equation. Now I'm going to substitute all the things in my formula. So 2 plus 2 divided by 10. So I'm going to substitute all the things in my given formula and I'm going to get the answer 2.1. And for next iteration, so it is my second iteration, then I'm going to modify my formula. So for my second iteration, what's the formula? x1 minus f of x1 divided by f dash of x1. So what is x1 here? That is nothing but 2.1. And I'm going to substitute that 2.1 in my equation as well as in my f dash of x1. After substituting, I'm going to get the answer 2.0946. Now, this is the answer for my next iteration. So what is my next iteration? That is nothing but x3. Now, what is the generalized formula here? x3 equal to x2 minus f of x2 divided by f dash of x2. Now, what is x2? That is 2.0941. Now, I have the formula, that is x2 minus f of x2 divided by f dash of x2. So, what is the equation I have? X cube minus 2x minus 5. So, what is x cube? That is 2.0946 to the power 3. So, this is my equation. Now, for this equation, I'm going to substitute the value. And when I substitute, I'm going to get the answer, that is 2.0946. I'm going to get the answer 2.096. Now, dear student, if I consider my previous answer and my present answer, see, I have 2.0946. Even here also I have 2.0946. So, I'm going to stop my iteration. So, hence, the required approximate root corrected to 3 decimal place, and that is 2.095. So, this is the way I can able to solve Newton-Raphson method. Now, I am going to have my second type of question, that is show that a root of the equation x cube plus 5x minus 11 equal to 0 which lies between 1 and 2 and find the root by Newton-Raphson method and carry out 3 iterations. So dear student, if I consider this question, in the question itself they mentioned what is the root and when to stop the iteration. So what is the root I have here? That is 1 and 2. And when I want to stop, when I reach third iteration. Now, let me to solve this question. So, what I want to do at the beginning, I want to write the equation in the form of f of x. So, I will write f of x equal to x cube minus 5x minus 11. Now, so dear student, in the question they mentioned that the root lies between 1 and 2. So, 1 and 2. Now, according to Newton-Raphson method, I want to consider smallest root. Which is the smallest root? Here I have 1 and I have f of x as well as f dash of x. Before that, this is my Newton-Raphson formula. And if I consider Newton-Raphson formula, what are the things I required? I required x naught. So what is x naught here? That is 1. And what about f of x? F of x is nothing but my equation. Then what about f dash of x? That is nothing but I want to take the differentiation or I want to perform differentiation. So when I perform differentiation and whatever the answer I'm going to get, that is nothing but my f dash of x. So here, what is the equation I have? X cube plus 5x minus 11. Now, f dash of x equal to d by dx of x cube plus 5x minus 11. And when I take differentiation of x cube, I'll get 3x square plus 5 into 1. What's the differentiation of x? That is 1. And what's the differentiation of 11? It's constant, right? So it is 0. So what is my f dash of x? That is 3x square plus 5. Okay. And when I substitute this one in this equation, I'm going to get the answer 1.625. Now, for the next iteration, this is my x value. So, here I'm going to perform iteration 2. Then, what's the formula? x2 equal to x1 minus f of x1 divided by f dash of x1. And when I substitute the value, I'm going to get the answer 1.5106. Now, this is the x for my next iteration. And if I consider x3, what's the formula? x3 equal to x2 minus f of x2 divided by f dash of x2. Okay, and when I substitute the value, I'm going to get the answer 1.5106. So, I'm going to write the conclusion that the required root is 1.5106. So, this is the way you can apply Newton-Raphson method. And dear student, if you want to get exact as well as correct result, then you must know how to use calculator. So, dear student, I'm going to have my third question, that is using Newton-Raphson method, find out three square root of 37. So, 3 square root of 37, find and correct to 3 decimal place. That means use Newton-Raphson method to find 3 square root of 37 and correct to 3 decimal place. So in the question they mentioned what is my equation. Along with that they mentioned when to stop the iteration. But what about root? Here there is no roots are specified. So what I want to do? I want to use trial and error method. So here first what I want to do? I want to write this question in the form of f of x. So what I will do? Let x equal to 3 square root of 37. Okay, now I want to write this one in the form of f of x. Before that, what I want to do? I want to simplify this one. And how I am going to simplify? I will take 3 outside, that is x to the power 3 equal to 37. Now, what I'm going to do? I'm going to write this one in the form of f of x. And when I write in the form of f of x, that is x cube minus 37. Okay, so I got x cube minus 37. Now, what I want to do? I got the f of x. To find out f of x, that means to find out the root. What I want to do? I want to use trial and error method. That means I'm going to start substituting x value equal to 0. And when I substitute x equal to 0, I'm going to get negative answer. And next time, I'm going to substitute x equal to 1. Once again, I'm going to get negative value. And when I substitute x equal to 2, once again, I'm going to get negative value. And when I substitute x equal to 3, I'm going to get once again negative value. So what I want to do? Once again, I want to substitute x equal to 4. And when I substitute x equal to 4, I'm going to get the answer 27, and it is positive 27. So what I want to do? I want to stop the procedure here itself, because one I got negative sign and one I got positive. Now I'm going to write the conclusion that the root lies in 3 and 4. That means I just have the approximation about the root. That means root lies between 3 and 4. And in my Newton-Raphson method, whatever the smallest root I have, that is my x naught value. So it is my x naught value. So x naught equal to 3. Then what about f of x? That is nothing but my equation. And what about f dash of x? F dash of x equal to d divided by dx, x cube minus 37. This x cube can be written in the form of 3x square minus 0, because it's my constant. That means I want to perform differentiation. After performing differentiation, what is my f dash of x? That is 3x square. Now this is the formula I have. See, I have the formula. So what are the things I required? I required x naught. So what is x naught? It is 3. And what about f of x naught? That is nothing but my equation. Now what about f dash of 0? That is, after differentiating the equation, whatever the answer I'm going to get, that is my f dash of x. So f dash of x naught. Now I'm going to substitute the value in this equation. So after substituting, I'm going to get 3.3704. So this is my x1. Then if I consider next iteration, that is the second iteration, x2 equal to x1 minus f of x1 divided by f dash of x1. Now, once again, I'm going to substitute this value. Now, after substituting this one, I'm going to get the answer 3.3327. Now, if I consider third iteration, what's the formula? That is x cube equal to x square minus f of x2 divided by f dash of x2. So, when I substitute this one, I'm going to get the answer 3.3322. The question, they mentioned that correct to 3 decimal place. See here, if I consider this answer and the previous answer, I got 332. Here also I got 332. So, again replacing 3.332, once again I'll get the same answer. That means if I further continue the process, I'm going to get same answer again and again. So what I'm going to do, I'm going to write the required root, 3 square root of 37. Correct to 3 decimal place is 3.332. So this is the way I can able to apply Newton-Raphson method. So dear student, in my today's session, I started with how to solve the problems by using Newton-Raphson method. Dear student, in my next session, I'm going to discuss secant method and how to solve some of the problems by using secant method. Dear student, let's meet in the next session with the new information about secant method. Until that, keep watching and keep learning. Thank you.